Hi, Stuart here with more Elastic V7 and .NET Core 3.1. This is part 2. If you haven't seen the part 1 video, here's the link to it. You can find it on my YouTube channel, and you can find all the code in this demo on my GitHub. And it also, the previous video shows you how to use Docker Desktop to get a little Docker image with all the necessary Elastic bits running. And then, of course, we have, in part 1, we show you some of the basics of connecting to Elastic and doing some basic things. And we're just going to have a demo where we show you more things that are exposed by the API. Last time, we showed you how to configure Elastic running on Docker. It's probably the easiest way to work with Elastic. My demos on other technologies use the same sort of thing where I spin it up in a Docker container and then I work with it in Visual Studio. And we showed how to configure an Elastic client after you set up the settings. And you can see we did a bunch of basic queries, we did some simple operations, and we're going to do some more in this demo. So the first thing we're going to do is count the records that are indexed. This is very easy to do. We have a count response and it has a count object in it. Probably not a good idea to use this count to enumerate through the index. You're much better off doing a deliberate search and then enumerating through the results, which you can do in a paged way. But it is possible to expose the count property. Likewise, because of the way that we set up our person object last time, and we have an ID, and we're using that ID as part of the key in Elastic for each row. So one row equals one person. You can use that ID to do a simple delete, and it's as easy as client delete and passing in the ID that you want to delete. But you can also do deletions based on matching query criteria. And just like you built a query for getting back results, you can build a query to define the scope of the deletion. So in this case, we're saying, okay, we want to delete by query. We want to use our index name that we've been using, and we want to delete all the rows that meet the query criteria of term of MID equals ID. So essentially, we're just deleting a single row here, but it's important to know that this could be any valid query expression. So you could delete all the people whose first names start with an S. Or if you had a status column or something else, you could delete the rows. You could delete the rows older than a certain date. You could do any valid query that we showed you last time on which you can build an expression. And again, for the purposes of these videos, I'm using the Fluent interface. I happen to like the Fluent interface quite a bit, but you can also do it using the native syntax, which is essentially representing the JSON directly. The result is I'm going to end up deleting one record, record number 5. You can figure out if a document exists using a very simple existential query. This is an example of the convenience method that the underlying library provides you for developers. And we said, you know, the Elastic client is really great, and the helpers that are over the top of it that are part of the Nest NuGet make it even easier and more convenient. And so this is a nice example of that. Last time, of course, we showed get by ID. Again, very simple interactions that you would expect using any kind of an interface. Now we have a use case that is a little harder. One of the things that you often use Elastic Query for is to get much faster searches on data that might be in a database or several databases, or maybe a combination of databases and non-database sources or whatever, but that data changes over time. And so you have a use case where in addition to deleting records that have gone away, which we've shown you how to do in the previous example, we want to update an existing record that's changed. So let's say we're subscribing to changes from our SQL database, and we've detected that ID number whatever for person has been updated, and we want to replace the old contents in the index for that person with some new content. And it's a little bit more elaborate to do an update, but it's not much harder. There's just some subtle grammar that I've sort of worked out for you. They're good examples as well. I'm going to walk through this one in a little bit more detail because I think it's useful to understand underneath the covers kind of what it's doing. The first thing we're going to do is we're going to make the replacement record, right? So that's models.person make random, and we're going to replace the ID 7 that we were using in the previous example with the new thing. So the first thing I have to do is create a path to that document in the index. And to help you do that, there is the document path object that you can new up an instance of, pass in your model, and of course the type. And what you get back and end up feeding to the update method itself is a valid Elastic document path. So instead of having to work that out for yourself, you can use the document path class to do that for you. And it will have all the right attributes and it'll be well constructed. And then the second argument, right, that goes into the update is I want to say what I'm updating. And so I have an expression that I've built. In this case, I'm using U for update, and I'm saying that I am going to use the model that I provided above as the update. And then this operation would be largely asynchronous, right, in Elastic. So you could fire and forget at this point, and if you were doing reads, you'd get eventual consistency, right? It would, you would do a get on ID 7, or you do some query that includes row 7, and you would eventually get the result. But if you wanted to wait for Elastic to finish this operation, you can amend, right? This is fluent syntax, a call to refresh, and tell it that you want to wait till Elastic is done. This isn't a requirement to update the underlying model. Only the first part is. But again, for the purpose of this demo, we want to immediately see the change in action. So we're going to call refresh, which causes Elastic to recompute. And then when we call get record, we're going to see the new record we expect, as opposed to potentially getting a dirty read of the old record. And again, depending on your use case, you may or may not want to call refresh when you update a record. The same is probably true of delete, although deletes tend to be a lot faster and they're generally not a problem. But be aware that unless you tell it to refresh its index in the moment, that it will be by default eventually consistent. Thank you for your kind attention.